In today's video, we're going to take a look at using long division to help us integrate. Let's consider the example, the integral of 4x cubed minus 2x plus 3 divided by x plus 1 dx. Okay, so when I look at this particular integration problem, there's nothing that, comes to me as a particular technique. I don't see a relationship between the numerator and denominator such that I could use one as the derivative of the other or a multiple of the derivative of the other. So one thing I might consider using to simplify this problem or rewrite it is long division. Okay, so we're going to actually divide x plus 1 into 4x cubed minus 2x plus 3. Now, before I write my dividend, then I want to take a look at the terms. Same thing for the divisor as well, and make sure that my terms are in order of descending power. And in particular, in this dividend, I want to make sure that I've left a place for any missing terms. So I notice here that I have an x cubed term. I don't have any x squared terms, but I am going to leave a place for that. And then I have an x term, and then finally my constant. I'm going to write this as 4x cubed plus 0x squared minus 2x plus 3. I just want to make sure that I've got a place for each power of the terms in my dividend. Okay, so now we're going to take a look at the leading coefficient and the first term in our dividend, and I'm going to ask how many times can this first term go into this first term? Okay, or another way of looking at that is saying 4x cubed over x. Okay, and of course the answer to that is 4x squared. Okay, x will go into 4x cubed 4x squared times. So I say x goes into 4x cubed 4x squared times. Now I'm going to take this number and multiply it by each term in my divisor. So 4x squared times x is 4x cubed. 4x squared times 1 is 4x squared. Notice already, even though we didn't have an x squared term in our dividend, we have one now, and we needed a place for the x squared terms. Okay, also notice that the next thing we're going to do is subtract, and we have to subtract this entire expression, not just the first term. That's why I've included it in parentheses so that we remember that we need to distribute the subtraction to each term here. So 4x cubed minus 4x cubed gives us 0. 0x squared minus 4x squared gives me negative 4x squared. And then I bring everything else down. And we repeat the process. So now in this line, I can ask, how many times does x go into negative 4x squared? And the answer is negative 4x. Okay, and so our next step is to take this term and multiply it by each term in our divisor. So minus 4x times x gives me negative 4x squared. Minus 4x times 1 is minus 4x. And we subtract. So negative 4x minus negative 4x is going to be 0. Negative 2x minus negative 4x is going to be negative 2x plus 4x, so that's 2x plus 3. Okay, we can go one more time because x will go into 2x 2 times. and we multiply 2 by x plus 1, so we get 2x plus 1. Okay, and if we subtract, as we did before, we end up with a remainder of 2. Okay, so how do we use this remainder of 2? So far, up top, we know we have 4x squared minus 4x plus 2, and then with this remainder, it's positive, so I'm going to add it on. And if we could, we would go a step farther and divide x into 2, or the entire x plus 1 into 2. We can't, so we'll just write it that way. So our remainder is 2 over x plus 1. That's the last term. All right, so now that we've used long division to simplify this problem, then we can continue with our integration. We know that the integral of 4x squared is 4x cubed over 3, and then here we get minus 4x squared over 2 plus 2x, and then here we've got plus 2 over x plus 1. So I might rewrite this one as 2 times the integral of 1 over x plus 1 dx. Okay? And I can see that if I allow u to be x plus 1, then du is just dx. And I would just have 1 over u du. And of course we know the integral of 1 over u du is the natural log of u. So our final answer would be 4x cubed over 3 minus 2x squared plus 2x plus 2 times the natural log of the absolute value of x plus 1 plus c.